Triangles and trapezoids. So the area of a triangle is going to be your 1/2 times base times height. Or some of you think of it as base times height divided by 2. And then your area of a trapezoid, you have to add your bases, take half of it, and multiply by your height. Okay? Or add your bases, divide by 2, and then multiply by your height. So this says find the area of a trapezoid in which your base 1 is 8 inches, your base 2 is 5 inches, and your height is 6.2. Well, I'm just going to plug it right in to the formula. I'll write the formula first. So base 1 is 8, base 2 is 5, and my height is 6.2. So we plug that into the calculator, and I get 40.3. Let's see, that's inches, so it's inches squared. Two B says find the base of a triangle when you know the area is 15x squared. Okay. So this triangle has a height of 5x. So I will write the formula for triangle. Area equals 1/2 times base times height. We know the area is 15x squared. We don't know the base, and the height is 5x. So we're just going to go about solving this now. First thing I would do is maybe get rid of that 5x right away. So let's divide by 5x. So if I divide by 5, 6 on this left side, I should get 3x. And then I still have my 1/2 b over here. To divide by 1/2 is the same thing as multiplying by 2, so that gets rid of that. Multiply by 2. Oopsies. So 6x is equal to b. And I guess if we want to label that, 6x centimeters is our base. And it's always a good idea to plug it back in. If you take 6x times 5x and divide by 2, you should get 15x squared, and that's what we wanted. Moving down a little bit, I've got 2c. So it says find the second base, b sub 2, of the trapezoid in which the area is 231 millimeters squared. Well, I'm going to write my formula for the area of a trapezoid, and then I'll fill in my knowns. The area they give us is 231. My base 1 is 23. We have to find the second base, and my height is 11. So I'm going to solve this by first dividing by 11 and then multiplying by 2. That'll get rid of these two. So when I divide 231 by 11, I get 21. And then when I multiply it by 2, I get 42. So I have 42 equals 23 plus my base. I just need to subtract my 23. And I'm left with 19. And that is my answer for the second base, 19 millimeters. Um, 2D looks quite easy. I didn't realize that when I put that on here, I guess. But the area of the triangle, you're just going to have 1/2 times base times height. So 1/2 times base times height. You need to find the base. So we're going to use the Pythagorean's theorem again. So you have your a squared plus b squared equals c squared. And so you have 12 squared plus b squared equals 20 squared. And you can solve that. So we have 400 minus 144. So b squared is 256. And b is 16. So I'll plug that in here. So 1/2 times 16 times 12. So 96. 8 times 12. I get 96. See, this is where I need Evan to tell me, yep, that's right. 96 meters squared. Moving on to rhombi. Rhombuses and kites. Okay, rhombuses and kites. So the diagonals of a rhombus or kite are perpendicular, and the diagonals of a rhombus bisect each other. So those are key things that we'll need to know in order to solve some of this. So remember that you have diagonals 1 and 2, and when you multiply those and multiply by 1/2, you'll get the area, whether it's a rhombus or a kite. So this says, find the second diagonal of a kite in which the first diagonal is 14 and the area is 232. So if I write my formula, area equals, 1/2. Wow. I think I should start over. Times D1 times D2. So my area is 238. And 1/2. D1 they give us is 14. And D2 we need to find. So we're just going to take 238, and if I do this right away, it'd be 7. So if I take 238 divided by 7, I get 34. So D2 equals 34 inches, and it's always a good idea to double check that, which I just did, and it's good. Let's move on to the area of this rhombus. This we're using some algebra, but it's the same formula. Area equals 1/2 times the first diagonal times the second diagonal. So we're going to, oh, this will be good. We need to FOIL. So I like this. This is good bring back to Algebra 1. So I'm going to fill in my knowns. Okay. Now when you have a binomial times a binomial, you will need to FOIL. And when you multiply, I'm going to multiply this, but I can multiply it to whatever I want. I'm going to multiply it to this one because if I do that first, it'll be easier numbers. Okay, so I could multiply this times this first and then multiply what I get to that, or I could multiply these first and whatever I get to that to multiply it. I'm going to multiply 1/2 times my 14x minus 6. So what I have when I do that, I'll still have my 8x plus 7. Wow. And when I multiply 1/2, I get 7x minus 3. Now, hopefully you didn't forget how to FOIL. So 8x times 7x is 56x squared. 8x times negative 3 is negative 24x. 7 times 7x is 49x. And 7 times negative 3 is negative 21. And then you just need to combine your like terms, which is your negative 24 and your 49. So you have 56x squared plus 25x minus 21. And that is your area, centimeters squared. I may need more room for this one. Okay. So find the area of the kite. So we know information, but we don't know enough information because we need to know the whole diagonal. And we only know this part, and we don't know this at all. But do remember, the diagonals bisect each other. So really, we have right triangles in here. So we can use Pythagorean theorem to figure out the sides we're missing, or the lengths we're missing. So on this one, if I look at this triangle right here, I don't know this. I shouldn't have labeled it X because that's X. Okay, but that's unknown. But I know this side is 35. So I can use Pythagorean theorem to say 35 squared minus 28 squared and figure out what this length is right here. I got that. That's 441. So that means that length is 21 right here. Now the cool part about kites is this is also 21 here. So I know my diagonal, one of my diagonals is going to be 42. So we'll call that diagonal 1. Okay. But I still have to find this part right here. Okay. But we do know this is 29 inches and this is 21 inches. So we can use Pythagorean theorem again to find just this part right here. So 29 squared minus 21 squared. 29 squared minus 21 squared, that's 400, which means this x right here, this length here is 20. Okay, so 20 plus 28, that means my other diagonal is going to be 48. Okay, so then we just need to plop it into area equals 1/2 times d1 times d2. When I figured it out, I got 1,008. So 1,008 inches squared. That is all for 10.1. It was a lot. I know I just had, this is an 18-minute video. Oh, good gosh, it's not all. Here's one more. We should probably do this one real quick. Find D2 of a rhombus in which D1 equals this and area equals that. Well, as you know, you have area equals 1/2 times D1 times D2. We know our D1 is 3x. We don't know our D2, that's what we're looking for, but we know our area is 12xy. So I'm going to I'll divide by 3x, and then I'll multiply by 2. So when I divide by 3x, I get 4y equals 1/2 times D2. Multiply by 2, I get 8y. And I can put a label on that. Looks like meters. Ta-da. Now, I'm going to let you get to your assignment. Please let me know if you have questions, and we'll talk to you later.